Alternating currents, class number 9. In this class, I am going to discuss AC generator. In this topic, we have to cover following subtopics: basic introduction of AC generator, principle of AC generator, label diagram, expression for induced EMF, variation of induced EMF with time, and finally, related questions. Hello students, welcome in my class. Today we are going to discuss a very important topic and the last topic of chapter alternating current, that is AC generator. In this chapter we have discussed so many topics in different classes, and we have discussed RMS value of AC, average value of AC, current through resistor, inductor, capacitor. We have also discussed LC oscillation, LCR series circuit, power consumed in AC circuit. Now we are going to discuss how alternating current can be produced. How alternating current can be produced, and it is produced by AC generator. So now we are going to discuss AC generator. First of all, what is AC generator? It is a device used to produce alternating current. It is a device used to produce alternating current. It is a device used to produce alternating current. Now question arises, on which principle AC generator works? The main question is this: on which principle AC generator works? Then we can write the principle of AC generator. Principle of AC generator, and that is very famous Faraday's law of electromagnetic induction. It is based on Faraday's law of electromagnetic induction. It is based on Faraday's law of electromagnetic induction. That is a very important topic. Before discussing AC generator, we will discuss what is Faraday's law of electromagnetic induction. It is based on Faraday's law of electromagnetic induction. So in previous chapter, that is electromagnetic induction, I think you all have discussed that whenever there is change in magnetic flux, what is Faraday's law? Very simple. Whenever there is change in magnetic flux linked with a circuit, EMF is induced in the circuit, and the induced EMF lasts so long as the change in magnetic flux continues. It means whenever there is change in flux, there will be induced EMF. If there is no change in flux, there is no induced EMF. Now we know that flux is represented by phi equals to BA cos theta. Magnetic flux is given by phi equals to BA cos theta, where B is magnetic field, A is area, and theta is the orientation between the coil and the magnetic field. Or we can say theta is the angle between area vector and magnetic field with the coil. Area vector and magnetic field. Theta is the angle between area vector and magnetic field, or it can be also known as orientation of the coil or orientation of the magnetic field. This is orientation of the coil or orientation of the magnetic field. Now here we are changing theta. In AC generator, what is the basic concept? How flux is changing? That is very important point. Just we will discuss this diagram. In AC generator, we are changing theta. In AC generator, we are changing theta, or we can say orientation between the B and A, or we can say orientation is changing in this AC generator. Orientation changes, theta changes, value of cos theta changes, phi changes, and therefore there is induced EMF in the coil. So that is the basic principle of AC generator. In AC generator, what we are doing? We are changing the orientation between magnetic field and the area vector of the So this is the basic principle of AC generator. Now since in AC generator there is change in orientation, now by this diagram we are going to see how orientation changes. So here I am discussing this diagram. These are two poles of a strong magnet, north pole and south pole. These are strong magnets, and a coil that is known as armature. This coil is also known as armature, that we have also discussed in class 10. This coil is known as armature. Here this coil is having this axle. This is the axis of the coil. This is the axle of the coil. Here the coil is placed in this position. Now if by any means, I am using the word by any means because here in AC generator we have to rotate this coil. If this coil rotates in magnetic field, EMF will be induced. So let us suppose we are rotating the coil. Now we can see, we can understand by this. Let us suppose this is north pole, this is south pole. Initially, the direction of magnetic field is this: north pole, south pole. Therefore, direction of magnetic field is. And let us suppose initially the coil is just placed like this. Therefore, area vector of the coil will be like this. This is area vector of the coil. This is direction of magnetic field. It means angle is 90 degree. But as coil rotates, I can mark like this. This is the area vector of the coil. You can easily understand, as coil rotates, the area vector will change, or we can say area vector will also rotate. With the rotation of coil, the area vector will rotate, but with the rotation of the coil, area vector of the coil will rotate, but the magnetic field is uniform, and that is also constant. It means angle between area vector changes. Angle between magnetic field and area vector changes. In some AC generator, we can also use a concept in which coil is fixed and magnets are movable. But in both the cases, there will be change in the angle between area vector and the magnetic field. As this coil rotates, angle changes, and if angle changes, there will be some induced EMF. And in AC generator, the initial coil, or we can say this rotating coil, is connected with the external circuit with the help of slip rings and carbon buses. It means carbon buses and slip rings are used to connect this coil with the external circuit, and here we will get alternating EMF, or we can say AC current. AC alternating current we will get here. Between these two terminals, we will get alternating current, or we can say alternating EMF. So this is the basic introduction of AC generator. These are the two poles magnet. Coil is rotating with the help of axle between the two poles of magnet. Then theta changes, and when theta changes, then value of cos theta changes, and therefore flux changes. And if there is change in flux, then there will be some induced EMF. So that is the basic concept of AC generator. Now we are going to derive, because here we have to find out the expression for alternating EMF or alternating current mathematically, that we have to derive. And for this purpose, let B, A, N, omega. These are the main four parameters that we have to consider here. B is the intensity of magnetic field. B is the intensity of magnetic field. A is the area of coil. A is the area of coil. N is the number of turns. N is the number of turns in the coil. Omega is the angular velocity. Omega is the angular velocity of rotation of coil. Omega is the angular velocity of rotation of coil. So we have considered four parameters: B, magnetic field; A, area of coil; N, number of turns; and omega, angular velocity of rotation of the coil. These are the main four parameters that we have considered. Now we will write the expression for magnetic flux, and then we will see how magnetic flux changes, and if magnetic flux changes, then we have to find out induced EMF using Faraday. So these are the four parameters B, A and omega. Now we can write the value of flux phi. Phi equals to B dot A. Phi equals to B dot A, or we can say BA cos theta. And since angular velocity of rotation is omega, therefore we can also write BA cos omega t. Phi we can write BA cos theta, or we can also write BA cos omega t, because omega is the angular velocity, therefore theta can be written as omega. This is the magnetic flux associated only with one coil, or having a coil only one turn. But if we consider a coil of n turn, because we have to consider so many turns so that EMF can be produced for much more magnitude B dot A, and it means we have to produce, or we want to produce more magnetic field, therefore we have to use a number of turns, not a single turn. Therefore, it can also be written as like this. This is the flux related with one coil or one turn coil, and this is for n turn. So we have to multiply it by n. So here n is the number of turns. Therefore, finally we can write phi equals to nBA cos omega. This is the magnetic flux associated with the coil at any instant of time. Phi equals to nBA cos omega. Now you can easily understand, if this t changes, as time changes, angle changes, and therefore value of flux phi also changes, and if phi changes, then EMF will be induced, and that we have to calculate by using Faraday's law. Now we know that according to Faraday law, induced EMF E is given by minus d phi by dt, or we can say negative of rate of change of flux will be equals to the magnitude of induced EMF. Here we have already discussed this minus sign is according to Lenz law. Lenz law means direction of induced EMF will be in such a way that it opposes the cause which produces it. That we have already discussed in chapter electromagnetic induction. So E equals to minus d phi by dt. Now what we have to do? Minus d by dt, and here we have to put the value nBA cos omega t, nBA cos omega t, and now it becomes minus n constant, B constant, A constant. These are the constant quantities, therefore nBA. Now we have to differentiate cos omega t, that is minus omega sin omega t. And finally we can write this minus minus become plus nBA omega sin omega, nBA omega sin omega t, that is the value of induced EMF E equals to nBA omega. Now this nBA omega, this is all constant quantity, therefore it can be written as E naught. Now by getting this expression E naught sin omega t, I think you all are able to understand that this is alternating EMF, because we have already discussed that alternating EMF is of sinusoidal function, or we can say sinusoidal nature, E equals to E naught sin. Now we will discuss what will be the value of EMF for different values of time and how it behaves like alternating EMF. So this is the expression for alternating EMF E equals to E naught sin. E equals to minus d phi by dt minus d by dt of nBA cos omega t, and then if we differentiate this, we get minus omega sin omega t, and finally we get E equals to E naught sin. Now we are going to understand how it behaves like alternating EMF. equals to E naught sin omega. E equals to E naught sin omega. Now if we consider different values of time, then omega t will be different, that is theta, and finally we get E equals to E naught sin. Let us suppose initially t equals to 0. Initially t equals to 0, therefore theta will be 0 because theta equals to omega t, theta is 0, and therefore E equals to 0. T equals to 0, theta 0, E equals to 0. But if t equals to t by 4, we can say 1 by 4th of the time period, and in that case theta will be equals to pi by 2. We know that theta equals to omega t, and omega is already 2 pi by t, and if you multiply it by t by 4, you will get pi. Theta equals to pi. Therefore we get theta equals to pi by 2. If theta equals to pi by 2, then E will become E naught sin omega t, sin 90. Sin 90 will be 1. Therefore E equals to E naught. If t equals to t by 2, then theta will be equals to, what will be theta? Pi. Theta will be pi, and therefore E equals to again 0, because you know that sin pi equals to 0, E equals to 0. Then if t equals to 3t by 4, then theta will be equals to 3 pi by 2, that we can say 270, and in that case E will be minus E naught because sin 270 is minus. And finally we can say t equals to t, then theta will be equals to 2 pi, and you know that sin 2 pi is 0, therefore. Now if we observe this data, we can easily understand that the value of EMF initially 0, then it starts increases, become maximum, that is E naught, or we can say peak value, then it starts decreasing, becomes 0, and then it moves in opposite direction, or we can say direction changes, and this EMF is minus E naught, and here it is E naught. It means polarity is changing after a fixed interval of time, and that is the alternating current or alternating EMF. And now we can also represent it by a graph, that is sine curve. So I think you all are easily understanding this. We can represent this by using the graph. Here it is 0. This is the variation. This is the variation of alternating EMF with time. Here the equation we can directly use, E equals to E naught sin omega t. This will be the peak value. This is also peak value in minus. Here it is minus. Here we can put the angle. At this point, angle will be pi by 2, or time will be t by 4. Angle is pi by 2. Here we can write angle at this point is pi by 2, and time is, here time at this point the time is t by 2. Here the time is 3t by 4, and again the time becomes. So by this curve we can easily see that the value of alternating EMF or value of EMF generated by AC generator increases in value, magnitude increases, it becomes maximum at this point, then it starts decreasing, becomes 0, and then again it starts increasing, or again it starts changing towards negative direction. This is positive, this is negative, again positive, again negative. It means the EMF produced in AC generator is of alternating nature. And if E equals to E naught sin omega t, and let us suppose R is the resistance of coil. If R is the resistance of coil, then alternating current I can be written as E by R, or that can be written as E naught by R sin omega. E naught by R sin omega t, or finally we can also write I naught. So this is alternating current, this is alternating EMF. And when summarizing this topic, what is the basic principle of AC generator? Electromagnetic induction. AC generator is a device which is used to produce alternating current. It is based on the phenomena of electromagnetic induction, or we can say Faraday's law of electromagnetic induction. In AC generator, mainly we are using the concept of change in the orientation. Here we are changing the orientation. By changing the orientation, flux changes, then EMF is induced in the coil. And we can also understand in AC generator, we have to rotate the coil. Coil will be rotated by using some mechanical arrangement. It means we are providing mechanical energy, and that mechanical energy is being converted into electric energy. It means in AC generator, electric energy is produced or electric energy is generated at the cost of mechanical energy. It means mechanical energy changes into electric energy, or we can say AC generator is a device which converts mechanical energy to electrical energy. And which type of electrical energy? Alternating current. That's why it is known as AC generator. Now we can consider one question. E equals to E naught sine omega t. This is the alternating EMF generated by a generator. E equals to E naught sine omega t is the alternating EMF produced by a generator. What will be EMF? What will be EMF if number of turns and frequency is doubled? If number of turns and frequency is doubled, then we have to find out new value of the alternating EMF, and for that purpose we must know the value of EMF. This expression is with the sine omega t, but we must know what is E naught. This E naught is not a universal constant. This is the peak value of alternating EMF in particular condition or particular set of combination or particular set of variables. Here we have changed two quantities. Number of turns have been changed and omega have also been changed. Therefore, what will be the new EMF? For that purpose, we must know the value of this E naught. It can be written as NBA omega sine omega. Just we have seen that E equals to NBA omega sine omega t. It means this is our initial EMF. According to the question, this is initial EMF. Now what changes we have made? Number of turns become double. Frequency also become double. Then what will be the changes? First changes in the peak value and second changes will be here. Therefore, we can write E dash equals to NBA omega. This N become double. This omega also become double. Therefore, we have to write 4NBA omega and sine omega t. And here we have to write 2 omega. And this quantity can again be written as like this. Therefore, 4 E naught. So by this way, we can solve the question related to AC generator. In this case, new EMF will be 4 E naught sine 2 omega. It will be sine 2 omega. 4 E naught sine 2. So this is the question related to AC generator. Question number 2. Alternating EMF produced by a generator is given by 310 sin 157t, and the resistance of the coil is 10 ohm. E equals to 300 sin 157t. Resistance of the coil is 10 ohm. You have to find out IRMS and I average for half cycle. IRMS and I average for half cycle. So how we will solve it? First of all, IRMS. This IRMS can be written as ERMS upon R, and ERMS can be written as E naught by root 2. No, we are having that E naught is 310 root 2 and R will be 10, and we can solve it. It will be RMS. 310 peak value of EMF, root 2 and 10 ampere. I average for half cycle. I average for half cycle 2 I naught upon pi. That we have already discussed. I average will be 2 I naught upon pi, and then we can also write 2 by pi I naught. This I naught can be written as E naught by, and we can put the value 2 into 310 divided by pi into 10. By this way, we can find out the solution of questions related to AC generator. Yeah? AC generator we have discussed how it behave in alternating. So this is what about alternating current produced by AC generator. Thank you.